Hello world, what is going on? It's good to see you back here on the channel today for another video. And today we'll be looking at the fourth exercise of Codility lesson 5, which is called MinAvgTwoSlice. And we will use math to prove that we don't need to get all the subarrays inside of an array to get the minimum average of that array on any subarray. And we can do that by just analyzing the segments of length 2 and length 3, and we would do that with a reduction ad absurdum to prove that we only need segments of length 2 or 3 to find the minimum average of a subsegment inside an array. So without further ado, let's get at it. Okay, so as always, let's go ahead and check the exercise, MinAvgTwoSlice on Codility lesson 5. We're going to read this in Python, and it says, a non-empty array A consisting of n integers is given. A pair of integers p, q, such that n is bigger than q and q is bigger than p and p is bigger than or equal to 0 is called a slice of array A. Notice that the slice contains at least two elements. The average of a slice pq is the sum of ap and ap plus 1 and so on up to aq divided by the length of the slice. To be precise, the average equals to the sum between a at p and a at q divided by q minus p plus 1, the average. So we are given an array here and they are calculating the average of the slices. So here in this example, the average of min length 2 that has the lowest average is a1 to a2 because the average here is 2. So the goal is to find the starting position of a slice whose average is minimal. So write a function that given a non-empty array A consisting of n integers returns the starting position of the slice with the minimal average. If there is more than one slice with a minimal average, you should return the smallest starting position of such a slice. For example, in the array A given above, the function should return 1 as explained above because 1 is the starting position of the array that contains 2 and 2. So write an efficient algorithm for the following assumptions. N is an integer within the range 2 to 100,000 and each element of array A is an integer within the range minus 10,000 to plus 10,000. So the first thing that we need to see here is that the upper limit is 10 to the 5. So if you take the naive approach and run this in O(n) squared, that would be 10 to the 10, which is not acceptable because it's bigger than 10 to the 8. So we need to find a linear solution to this exercise. So let's go ahead and check the problem explanation. Okay, so the important thing here is to understand that we don't need to check different sizes of subarrays inside the array or different slices to get the slice with the minimal average. So the question is, how many elements at most do we need to check to find the slice with the minimum average? So let's go ahead and start by analyzing a segment of 4 elements, and we're going to divide this into 2. The segment with the first 2 elements and the segment with the last 2 elements. So the first thing that we're going to do is to do a reduction ad absurdum to prove that if we divide an array of 4 elements into 2 subarrays of 2 elements, both of those segments or slices can't have a bigger average than the average of the 4 elements. So to do this, we're going to say that the average of the first 2 elements is going to be bigger than the average of the 4 elements, and we're going to check that the average of the last 2 elements is bigger than the average of the 4 elements. To do this, we're just simply going to resolve this inequation. We're going to multiply both sides by 4, and we're going to have a condition for this to be true. That is that a plus b has to be bigger than c plus d. And when we do this for the second segment, meaning the last 2 elements of this subarray, we're going to see that c plus d has to be bigger than a plus b. So if we compare both of those cases, we're going to have an absurdum here. So a plus b has to be bigger than c plus d, but also c plus d has to be bigger than a plus b. So that doesn't exist, that is impossible. So we prove here that the average of the first 2 elements can be bigger than the average of the 4 elements if the average of the last 2 elements is bigger than the average of the whole pack as well. So this case won't happen. So what we arrive at is when we do the mathematical analysis of this, is that this is actually the condition. If the average of the first two elements is bigger than the average of the fourth element, then the average of the last two elements has to be smaller than the average of the four elements. So this proves that we don't need to check an array of length 4, we just need to check an array of length 2, because in each array of length 4 there is at least one subsegment composed of two elements that has an average that is smaller than the average of the fourth elements. And if we assume that the average of the first two elements is equal to the average of the whole, then the average of the last two elements also has to be equal to the average of the fourth elements. This works as well for arrays of length 5. I'll let you do the inequations the same way that we just did them before, and we're going to see that if we divide the if we divide the array of 5 elements into an array of 2 and an array of 3, the same conditions apply. If one subarray, let's say the one that has 2 elements, has an average that's bigger than the whole average, then the average of the last 3 elements has to be smaller than the average of the 5 elements. But if you're curious like me, you'll have this question: is there a case where the average of a slice of 3 is smaller than any of the 2 slices of 2 that construct that slice of 3? Because in the previous example we saw that we can build here an array of 3 elements, and I wanted to see if C or D has an average smaller than C, D, and E, or D and E has an average smaller than C, D, and E, to not have to check the subarrays that have 3 elements. So the question is, if the average of ABC is smaller than the average of A and B, and the average of A, B, and C is smaller than the average of B and C. I want to understand if there is a case that complies with this idea. So let's analyze this. As always, we'll have simple inequations here, and from these inequations we'll have these inequations here that are just the solution, and we're going to need to find from these 2 inequations if there are values that comply with these inequations. So that's pretty simple, because B is on the right hand side of both equations, so we can assign a big value of B and small value for A and C. And with this we're going to build an array of 3 elements, let's say 1, 10, and 1. And we can see here that if we take the average of the first 2 elements and the average of the last 2 elements, in both of these cases is 5.5, this is still bigger than the average of the 3 elements, which is 4, because this is 10 plus 2 divided by 3, so that's 12 divided by 3, and that's 4. So there is a case where we have an array of 3 elements where the average of 3 elements is smaller than any of the combinations that could happen by dividing this array of 3 into 2 arrays of 2. So we do need to check the arrays of length 3. So with this simple idea, we're going to check the elements that have length 2, sorry, not the elements, we're going to check the subarrays of length 2 and 3, and we're guaranteed that we're going to find a minimum average by analyzing just these 2 cases. So we won't need to do the naive approach, and we can just check subarrays of length 2 and 3 to find the minimum average across all of the array. So let's go ahead and implement this into code. So we're back here at Codility. Let's go ahead and start this test, start the test. Let's select Python here. We're going to remove this. And the first thing that we need to do is to declare a mean average overall, and we're going to start this at a big number like 20,000, because no average on the array is going to be bigger than that, because the elements just go up to 10,000. And we're going to define the mean start position at 0, and then we're going to iterate over all the elements in the array from 0 to the length of A minus 1, because we're going to check that element and the next element to get the subarrays of length 2. So that's the sum of the 2 is going to be A at I plus A at I plus 1, and the average of these 2 is going to be the sum of the 2 divided by 2. and we're going to check here if the average is less than the global or the mean average found so far. Then we're going to assign this to the mean average of 2, and the start position is going to equal I. And then we have to check the case of slices of size 3. So if I plus 2 is still less than the length of A, then we're going to calculate the sum of 3. So the 3 sum is going to be the sum of 2 plus A at I plus 1, sorry, I plus 2, because we already have I plus 1 here. That's A at I plus A at I plus 1 plus A at I plus 2. And the average of these 3 elements is going to be the 3 summation divided by 3. And we're going to check as above if the average of 3 is less than the average, sorry, the mean average found so far. Then the mean average found so far is going to be equal to the average of 3, and the mean start position is going to, sorry, this is 3, and the mean start position is going to be I. So with this being done, we just need to return the mean start position, and that should be it. Let's check if this is working correctly for the test cases. It is. Let's go ahead and submit this task. And we got a result back. We see here that, as expected, we are running the solution in ON time, and it works for all the cases. Okay, so that was it. In today's video, we saw how dividing an array of length 4 or 5 or even bigger, we can have segments that have a minimum average that's smaller, or that can be smaller than the average of the 4 or 5 elements that are in the array. And with that solution, we can take or we can avoid taking the naive approach and take a smarter approach and run this solution in ON time, which complies with the exercise's upper limit. So if you like the content, hit the like button, subscribe to the channel, and share it with someone if you think it would be valuable for them. I'll see you on the next video. Bye!